Alright, so today I'm going to do something I haven't done in a while, and that is make an informational video. And this time it's going to be about acids and bases. So there are actually 3 different definitions as to what an acid or base is. And the first is alkeneous, at least I think that's how you pronounce it. And that states an acid is anything that uses a hydrogen ion, which is basically like a hydrogen atom, except it doesn't have an electron, it's just got a proton, and then has a positive 1 charge because of that. And then a base is anything that uses a hydroxide ion, or which has a negative 1 charge. And like to explain this, say we have like HCl, and then which is hydrochloric acid, then NaOH, or sodium hydroxide. That would give us HOH, or water, plus then NaCl, or regular table salt. And the key thing about this is the hydrogen has to react, and the hydroxide has to react for it to be a hydrogen acid base reaction. And so that's what makes it alkeneous, is the fact that the hydrogen is reacting or the hydroxide is reacting. That's the key thing about making it an acid or a base. Now, the second definition is Bronsted-Lowry, and this doesn't actually contradict alkeneous, it just expands upon it. And it says that a acid is anything that donates protons, which is, a proton is basically a hydrogen ion. And then a base is anything that accepts protons, which does not necessarily mean it has to have a hydroxide ion. For example, let's say we have hydrochloric acid again, and then NH3, or ammonia, and this would give us NH4, and then plus Cl, which would actually be that atomic, so we'd have 2, but I'm not going to worry about getting to that. Now, according to both Arrhenius and Bronsted-Lowry, HCl is an acid because it's donating the hydrogen ion, and it's also kind of donating the proton. So, according to both of them, it's an acid. However, according to Arrhenius, ammonia is not a base because, as you can see, there's no hydroxide ion. But according to Bronsted-Lowry, it is because, as you can see here, it's accepting the proton. So, the key thing here is that Bronsted-Lowry just has to accept a proton. It does not necessarily have to have a hydroxide ion. Now, the third definition is the Lewis, which is actually a bit different. And it says that an acid is anything that accepts a pair of electrons, while a base is anything that gives them off. And this can be seen by, let's say we have the same example of HCl plus NH3, which gives us NH4 and chloride, or Cl. And the key thing here is what actually happens is this says that these two actually split apart, and then the hydrogen ion actually goes over here, and this supposedly has an extra pair of electrons, so it kind of then joins with that. So the hydrogen ion takes the electrons from there, and then the ammonia gives it to the hydrogen ion. Because if you think about it, the hydrogen ion is just a proton, and it needs 2 electrons to have a full valence, or electron level. So the key thing here is that donates the electrons and that accepts it. So that's how that works. But yeah, I hope you guys like it. I hope I wasn't as confusing as I can be sometimes, and you guys learned something. But that's it for today, and see ya.